We are live and we're getting started, ladies and gents. We are live and we will continue. But we will continue our cosmology and physics and astrophysics, cosmology, physics and astrophysics studies and discussions. But before that, I am going to go do a couple of things. I am going to put my laundry away that I just got from downstairs, and I will do the settings on my other thing, and I will feed the kitty cats their foodies. So give me a moment and let us gather and let us get started for the purposes of tonight's live. And I'll show you this book too. All of the books are at your services here tonight, and myself and my face will be sitting down soon as well, my loves. Hello, Rob Noxious. How are you doing? How are you doing? So indeed, I'm also picking up on a bit of a poopy situation here that Sachi Mama has created in the hallway. I will be right with you, ladies and gents. Please do like, share, and subscribe. Thank you so much. If one of the mods is here, please do ask people to like, share, subscribe, and get it going, get it started, and all that good stuff. Excuse my poop clearing at this moment, but I do see. Hello, Scott is here. Thank you, everybody, so very much for joining. Please, can people put in the chat to like, share, and subscribe, and I will be with you shortly. Also, can we get 10 likes? Thank you so much. gracious, indeed Sachi Mama had left a huge gift for me. And thank you all so much for being here. Hang in there, guys. I'm gonna do their meal time here. How is everybody doing tonight? So we are going to talk once again about black holes, and then we will move on to the topic of tonight, which will be the Big Bang. You can also put your questions in the chat. As always, you can take your questions as well. A lot is happening here. Their snack meal is now following. Indeed, a lot is going down in the kitchen. I just did the gym. Whoop. Whoop. Whoopsie daisies. Can we get 10 likes, please? Thank you so much. I'm going to start a goal here really soon as well. Thank you guys so much. We're about to start. Let's see. Hi, Sachi Mama. Sachi Mama, could you please use the literary robot instead of the floor? That would be most delightful, if possible. I have 2 automatic toilets, but this cat really prefers the floor. It would be most excellent, Sachi Mama, if we could use the technology in order to go to the bathroom. They're getting their din-din. Here you go, Baji. Baji gets it downstairs, as in below the kitchen counter. And Fujisuji get it upstairs. They pick their spots. Here you go. Such good babies. Can we get 20 likes? That would be most excellent. Please do show some love. That will be so encouraging, and I will sit down with you very soon here indeed. Just happens to be a one-woman show here. Indeed. Got to take care of the children and myself. I did the gym, and I took the bus, and I got the laundry from downstairs. It's quite wet and cold. Actually less cold because it was in the teens and 20s, and right now it's in the 30s, which is practically summer. Practically summer in Boston, Fujisuji. Thank you guys. Could we get 10 likes or 20 likes, please? They are the most beautiful kitty cats, aren't they? producing the most beautiful turds as well. If you're hearing the cat Ginny run in the background, it is because of that. Physics will be ensuing soon here, guys. Very soon, as soon as the children finish eating and I put away the laundry upstairs. I have to just bring it upstairs, use the bathroom, and then I will be right with you. Do not go anywhere. Hang tight, guys. And can we get 10 likes? We are about to begin. Please do. Stay on. Thank you so much. And welcome the others in when they join, okay? Let's see. Everything's off. That should be on. Off and off. And off. And off. And off. And off. Oh, very nice. All right. Lights are on. I have to use the bathroom, but I will be back. I will be back. Oh, sorry, Sachi. Didn't mean to disturb you. You keep eating, baby. Mama loves you. Mama loves you. Don't you worry. Don't you worry. Shona Moni. Shona Moni to Tumi. Tumi to Shona. Okay. Be right back, guys. So sorry indeed for the delay. So sorry. So sorry indeed for the delay. I am here. Let me move these bowls out of the way. Hello. I am here with you guys. Do not doubt that. I am here with you. Just had to put on some lipstick and I brought some earrings with me to wear with you guys. I even brought my comb. I even brought my phone. Thank you for liking the live. Oh my gosh. And did someone did a super chat? Who did it? Oh, Wild and Fresh. I love this fresh super chat of yours. And I put a fresh lipstick on just for you guys. They're not upside down. They're just left to right. As in they're this way reversed. They're not this way reversed. As in they're not upside down. They are this way. Because of the camera on the phone reversing everything, even my face is actually, you're seeing it like that, unfortunately. So I guess you'll never know what my face is without that reversal. But I think it is going to be pretty similar. Stephen Sky reading. Sneaks in a second stupid chat. You mean super chat? Stephen, my friend, how art thou? So yes, I wore this pink top and this pink lipstick just for you guys. Some of you guys are getting distracted by the other people that are on the lives. I've seen some of you in those lives as I was decompressing and using the restroom and getting ready. So you guys better join us here on this live, and the studies are about to begin. I'm fixing my lipstick. There, okay. Let me get my water bottle. Cold water. Cold and fresh. from the taps of Massachusetts. Good evening, good evening, good evening. I do apologize for this extra time that it has taken for me to finally settle down. I am here and I hope you are here. Welcome one and welcome all. My favorite continents, welcome one and welcome all. I know Steven. Steven is my first member of this channel and he has shown his support for this work by becoming my first member. As I keep growing the channel, I will increase the content for members only and have more and more exclusive content for the members, but I do appreciate my members' patience as I continue to grow this channel. At some point, I will get the ability to start. Is there a booger in my nose? I hope not. I hope that if there is a booger, it is because of my screen having an issue or your screen having an issue. If you see any boogers, please blame your phone's screen having a booger, not my nose. I hope anyways. Absolutely everybody that is supporting my channel is absolutely my favorite. Scott, Harvard, Stephen, everyone. Gilbert, Sam T. What happened? Stephen! You're here. Yes, you'll send me a copy. I don't know what you guys are saying. I am not paying attention too much. Can we get 30 likes? So by the way, thank you everybody. Hello on King David. Okay, we're gonna say hi to everybody in just a second. I do want to say my welcome speech. Thank you everybody for being here. Welcome one and welcome all. We will be starting to discuss and conversate about our favorite topic, which is going to be black holes followed by the Big Bang. Thank you indeed for being here. And okay, thank you indeed for being here. Welcome one and welcome all. I do hope that you join. And this channel is Cats and Physics. We present my children, the kitty cats, my face, and physics, astronomy, cosmology, and astrophysics. I really hope that you join and that you like, share, and subscribe. If you're finding us right here, right now, please do subscribe so we can see you at many of our future lives here. Welcome one and welcome all. And please do start to enjoy and sit back, relax, and enjoy this flight. And welcome to all my continents: South America, North America, Africa, Eurasia, Australasia, Antarctica, all the oceans, all the neighborhoods, all the ponds, all of the islands, Caribbeans, Madagascar, Dominican Republic, Puerto Rico, Caribbean islands, US Virgin Islands, Venezuela. Everybody, welcome, welcome, and welcome. Let me put my earrings on. These earrings are just for you. As you can see, these are quite heavy. So because of my lateness, I am putting these on. Did someone do a super chat? Scott Romer! Scott Romer has done a $9.99 super chat. Thank you, Scott Romer. It is yellow in color. Thank you, Scott, for helping me with my goal for this live. So I started a goal for this live. I really do appreciate everybody's support to help me meet my goals for this live and for all the lives, because thank you so much. You're directly supporting me and making it possible for me to do these live streams and to continue sharing my education in physics and making all of this content. Thank you so very much. It really helps me. Thank you so much. And it helps me with my heating bill. At some point, I hope that it also helps me with my mortgage, because because I do live in Boston, where that's quite high. Thank you so much. Serving My Redeemer has sent a New Year's Eve 2026 gift. How delightful indeed. I am extremely grateful for all your support, everybody. Thank you so much for all your support. Serving My Redeemer, Scott, Stephen. Oh, I'm going to do the top fans here soon before we get started for the reading of tonight and the topic of discussion for tonight. It will become like a sleepy ASMR reading physics going on situation. So if you fall asleep, then that is fine. People do eat, sleep, live, and work to these live streams, I'd like to think. So go ahead, start relaxing and show us some love and support. I really appreciate you. What is happening? Is my ear hole a thing? Yes, it is. Okay. I wear earrings quite irregularly, so sometimes my ear piercing becomes quite tiny. But it is hanging, so I think it is there. Both my earrings are now on, guys, and I am now on, and we are now on, and the live stream is now gonna be happening with the physics. So now let me make sure all the buttons are buttoned. I see my light is on, very good, and I can clip things. Okay, good, okay, good. Tried to escape Jersey today at 11 kilometers per second, but couldn't because it turns out that I have mass and not that fast. Well, the 11 kilometers per second, you can actually do, you might need to be given some boost, but basically, you can have a speed that is lower than the speed of light. So 11 kilometers per second is a lot lower than the speed of light. The speed of light is 3 times 10 to the 8 meters per second. So it's a lot more than that 11 kilometers per second number. So 11 kilometers per second is the escape velocity from Earth. So the Earth's our planet Earth, its gravitational field can be escaped with 11 kilometers per second of escape velocity. But from a black hole, we were discussing how last night the speed would be the speed of light in vacuum, which is 3 times 10 to the 8 meters per second. So of course that is much higher, and that goes to show the much more extreme nature of the black hole's gravitational field. And initially black holes were just theorized, and people thought, well, there could be an object with so much more and extreme of a gravitational field where even light could not escape. And people, because light is something that they had now gotten new insights on with the special theory of relativity coming out in 1905, Einstein had already given us such a nice insight into the nature of light and the fact that it's an electromagnetic wave, and that its speed in vacuum is a constant. And from that whole special theory of relativity, we got the relative nature of space and time, and we got the mass energy equivalence. So all of this was gifted to us in the year 1905, quite right into the 1900s. And then, of course, we also got photoelectric effect from him, the Brownian motion also. So it was a very productive year for Einstein. He also contributed these other amazing things as well, all in that same year. But one caveat with the special theory of relativity was that it is a theory that is for inertial frames of reference only. Siri, do not talk to me. Go away, Siri.
Okay.
Sometimes sometimes that thing starts to talk to me in the middle of my sentences and quite abruptly scares me, actually. um, Anyways, so a special theory of relativity is for inertial frames, as in the frames of reference where there is no acceleration happening, the special theory of relativity will hold. That will be the good theory, the good mathematics. But then Einstein, of course, realized that you do have acceleration. For example, gravitation causes acceleration. And so, how to incorporate that into this relativistic theory, into relativity, in other words. So, for that, he would have to develop a more complicated, a bit more involved of a theory, which also accounts for something like accelerating frames of reference and gives you gravitation, explanation of gravitation in a relativistic manner. And with that, we actually got the general theory of relativity in 1916. By the time it's 1916, he has already come up with a more general, more generalized theory of relativity, which is the general theory of relativity, which gives us an upgraded theory for gravitation. Now we got into some of the details of exactly how that's done and what that means and things like that. For example, you of course keep on using the four space time. Four space time is something that he introduced with special theory of relativity itself, but now in order to bring in gravitation into the picture, he had to develop the mathematics a bit more. Okay. So that's what we find. And as soon as kind of this was being done, and as a sort of natural result of this being done, people actually wondered whether there was, could there be sort of a gravitational field, an object so compact, which has such an infinite sort of density or gravitational field that even light would not be able to escape it. It would kind of, the mass of this, or the object, the gravitational field of it, would bend space-time so much bending and so much curvature brought by this, that even light could not escape. And indeed, there are different pictorial sort of visualizations of this, explanations of this, that we can also go over. But that is how this theory of the black holes came to be classically, because, relativity is a classical theory. It does not incorporate quantum mechanics. So that's why we call it a classical theory. So that is what happened there. And one of the sort of foundational pieces to keep in mind is that a black hole is an object from which even light cannot escape, classically speaking. So 11 kilometers per second is much lower than that, and you can achieve it. I believe in you, but nobody can achieve the speed of light in vacuum, because you'd have to be light in order to do that, and you'd have to be massless, which light is. The particles that make up light are all massless. So, anyways, this was a bit of a summary of what we went over last night. Hopefully that was helpful. And if you're interested, please do go check out the entire live stream episode of last night. We've been going live quite often here. And please subscribe, and you can keep coming back to these live streams and catch these types of topics if you're interested. Baji Baba has just now joined me in the live as well. He's here in the living room. So once again, yes, we show my face, the kitty cats, and we cover these types of topics: astrophysics, physics, cosmology, astronomy. And we hope to get your support and more subscribers and people that can join for the lives. And we have a goal for super chats to help support these efforts. And we will be reading from the book, once again, Death by Black Hole by Neil deGrasse Tyson, again, because we also have a book club vibe going on with these lives. We reference several books. There are many, many books that we have covered already, and we continue to. And tonight we will finish up the black holes part, and then we will go on to the Big Bang part. Okay? So, if you have any questions, by the way, what I'll do is I'll probably in a few minutes, in a few seconds, I will start the reading. I'll do that, and then I'll look at the chat again for the questions and spend the rest of the live kind of going over that and whatnot. Okay. Hello, Lilith. How are you doing? Oh, Reese is here. Yay, I have one of my mods here. Hello, Sergey. Hello, Paul Gentile. Yes, the speed of light is a universal constant. The speed of light in vacuum is a universal constant. Somebody asked about that. Ooh. Hello, Wild and Fresh. Oh no. Sorry, 1 second. It seems my... Sorry, Fuji. Fuji had a hairball. All kinds of things are happening tonight. It's okay, Fuji. Mama loves you. It's okay, Mama will get it. Thank you, everybody. So, Reese is saying you don't have to attract some strange folks. Let's get that goal. I see. Oh, you have the books for me? Okay. I need to get a PO box. I do. Sorry. I'm making sure things are not... I am wearing lipstick. My theory puts the space-time continuum in the fifth. Okay. Is it true that not all giant stars become black hole because mass is greater? So, stars, when they die, so stars will eventually run out of nuclear power, right? A star is an object that is doing nuclear fusion in its belly. It has a nuclear reactor in its belly. The most massive ones will make like a core of iron. And at some point, because of details of nuclear physics reasons, oh my gosh! Hello, BKW. That's such a cool gift. Sent an oh dear. Thank you, BKWB9. Thank you so much. Love it. So, at some point, because of nuclear physics reasons, a star will die. It will start to collapse under its own gravitation because it is the other sort of situation that keeps it alive, which is its nuclear power and fueling the star, basically. It will run out of its own fuel. And in fact, the more massive it is, the faster that happens, because the more massive stars eat up more of their own fuel. They're burning quite literally, right? So then what happens is that gravitation will win at some point. There's not enough fuel to keep the star burning and doing that whole thermonuclear situation which is going on inside of the star. It's happening still, but not enough or fast enough or not as much. And gravitation starts to win. Then what happens is that there is a supernova. And again, what type of supernova, it depends on the mass and whatnot and other conditions of that star. But and even some more thermonuclear processes can happen during the supernova too. And we get even, some more elements out because, of course, the burning star has been making elements, heavier elements from lighter elements. And that's actually how we get elements at all. Anything heavier than hydrogen and helium comes from stars and their exact process that is being described above. So basically, once it goes through that gravitational collapse, which is the process of a supernova, at the end of that, it will all collapse down to a compact object, which will be sort of this dead star, or sort of what remains after the supernova is done. Things have been, blown apart. Some things have been kind of spewed into the surrounding space and whatnot to make gas clouds, which can, by the way, gas clouds like that or nebula can then eventually give rise to the next star and its planets, like what we come from. So the star kind of sharing its materials with the interstellar medium is actually how we are here. Because if all that material that it worked so hard throughout its life to make did not get distributed into the cosmos, then of course there would not be metal enriched and material enriched gas clouds that then become the birthplace of the next star system. So we have all these stars before us to thank for that. But pretty much what I'm trying to explain is, after all this is done and there was a star here, what will remain, right? That object, which is formed due to gravitational collapse of the star and that remains after the death of the star, also called a dead star, sometimes is called also a stellar remnant. So this is literally the leftover after the star has died. And again, depending on the mass of the star, the stellar remnant will either be a white dwarf type of compact object, or a neutron star type of compact object, or a black hole type of compact object, in that order of extremeness in gravitational collapse. So the more massive the star is, the more extreme its collapse will be, and it will make a more extreme compact object. The most extreme compact object is the black hole. So not all stars will make a black hole, because not all stars are equally massive. So our sun, for example, will make a white dwarf, which is a tamer compact object in that sense. It's not a black hole, right? More massive stars, I think something like, I should get the ranges of the masses of the stars for you, but the more massive stars, like maybe 10 suns worth and more, something like that, I believe is the right range, but I should verify and you should verify. The more massive stars will make something like neutron stars, and then the most massive stars will make black holes. So it's not the case that every star, when it's dying, will make a black hole. So it's not the case that every supernova ends up in a black hole. But a lot of massive stars, the most massive ones, have resulted in a black hole, and we have lots of black holes out in the wild, in nature, that we now find experimentally, observationally. So we know that it's not a crazy idea or anything, and what was once sort of uh, just in theory, what was once just theorized by general theory of relativity, is now actually experimentally found and digested, and we get it, and it's totally fine. It is not anything to really write home about anymore all that much, even though black holes continue to be intriguing, interesting, and fascinating objects and things that we like to talk about and understand deeply. But they're much more of a well-known thing at this point. But I will say that in 1916, nobody expected probably that they would actually exist in nature. And in fact, when we discovered pulsars or neutron stars, that is when people started to believe with more gusto that maybe black holes are actually a thing, okay? Because if something as extreme as a neutron star can exist, then just go a bit more farther in the extremities and you might just get a black hole. So yeah, hopefully that helps. When math shows they should also exist, I collapse every time I see you because, oh, thank you, Jay Franks. Thank you, Benito. The moon landing is real. We did go with humans. There have been people on the moon. I don't believe there has been a woman on the moon, but the moon landing is real, and but it's costly to go into space. Costs billions of dollars, and so there is sort of a funding and grant money situation going on with various experiments. And I don't know if you know this, but like all of the scientific experiments and things have to write proposals, and their proposals have to be granted the money, and they have to win money. You know, this is taxpayers' dollars generally that are used to do these experiments. And so it really depends. So like say somebody were to approve going back to the moon, and thank you for the gift, by the way, and the super chats. Really appreciate you. Thank you, JDub417. Hello. Thank you, JDub, for the gift. Ooh, and thank you, BKW9BG, for the super chat. Really appreciate you. Thank you, BK, for the super chat. Thank you, JDub. Really appreciate you. So basically, the moon landing was real. We definitely did go, and we did have some people land and step out on the moon and things like that. So that is not the big deal anymore either. I would say that is something we've accomplished. I think maybe they were just trying to figure out, that there are, it's a mission, right? Going to the moon is a mission. Even going to Antarctica is a mission, right? So even going to the Arctic is a mission. And sometimes, like, if not all the time, you actually need military support. Like going to Antarctica, you actually go on these military planes or vessels. So it's a mission. It's a logistical challenge and a mission to do these things. So imagine, like, so for example, I worked in Antarctica for some time, and going there is not a joke. The mission, it's a mission for the Air Force. In my case, the Air Force took me. It's a mission for them to go there, and it's a mission for them to get you out of there. And there are many logistics that play into that sort of thing. And actually, like, for example, for me, I had an on ice date but not an off ice date, so I had no idea when I would be able to come back to civilization. And that is because you there is so many things that are more important. They have to make sure everything is safe, that people are ready, that personnel is available, that they have enough rest, that there is enough supplies. There's just so much going on. One of the things also is Antarctica, you can't have garbage there. So all of the garbage, like food waste and whatnot, has to get shipped back. So we were told, like, please don't waste food, because it's like endless food, but don't waste it because the garbage actually has to be shipped back and it costs money. So all of this, I'm trying to give you some idea that it all costs money and it's a lot of logistics and it's not an easy thing to do. So now imagine going to the moon, right? It's an even bigger mission, needing even more logistics and organization and money and everything like that to figure it out. And if you don't have a really, really good reason, like a really good scientific mission and such, that can only be done on the moon, and that's why you're going, why would they fund it? There is limited money every year to fund various experiments. Lots of good experiments get canceled all the time because there's not enough money to go around. Like the NSF, you can look up, National Science Foundation is a source of money. My PhD was funded by NSF and NASA. And these organizations are government organizations, agencies that don't have money growing on trees. Like they have to make a decision every single year to accept some projects and reject some other projects. And people work really hard to write these grant proposals to then propose some project and experiment that they are able to do. And those people generally have years and years of experience and proven results from doing such a thing already, and then they get accepted. So I would imagine that probably the moon has certain issues, like, for example, they'd have to figure out, I'm not sure how developed the bases are, like, on the moon, right? I mean, Antarctica's bases are pretty well developed, and even then, it's not easy to just like go and live there and stuff. And they have to think about Antarctica is still on the Earth, so like it's the same gravitation and whatnot. Moon is in the space, like it, you way different. Like there's just I hope I'm making sense. Like the moon is not easy, guys. It's close, and sure we can go, but going is not always the end all be all. You also have to think about, like, if you want people there, what are they gonna eat? Where are they gonna poop? How are they gonna shower? How are they gonna do laundry? What can they get a chef up there? Because like, Antarctica has some of the best chefs. And that's because you're putting people at risk and you're putting them to these extreme conditions. So you have to feed them well. These are military missions. The military is fed well. So like, will a chef agree to go to the moon? What will be the power source? What will be the fuel source? Like, I wasn't allowed to drive in Antarctica, so there are drivers who are like really good at driving, and they drive. Like every time you say have to go somewhere, it could be like a very urgent thing with your experiment. You can't just drive yourself there. A driver has to come and pick you up and you go there. So actually it suited me just fine because I'm used to that. I like being driven around. I'm a passenger princess. But I'm just trying to tell you that it's not easy. Even Greenland is not easy. Even Antarctica is not easy. So the moon, even though we have the technology to go to the moon, having the logistics figured out on the moon is still not going to be that easy. And this is why we must appreciate Earth. We have power source on Earth. We can plug things in on Earth. We can dry our hair on Earth. You cannot do that on the moon easily. Like in Antarctica, we weren't, you're not allowed to shower every day. Or you're supposed to take really short showers. And depending on where you work, if it's the base, then you can shower. If it's a field camp, then you're supposed to take a bucket of snow that you plow yourself, and then you somehow heat it and you take a shower with that bucket every week or something. So we can't take these things for granted. Hope that makes sense. And also, like, people can die, and when people die, generally their family members want their body, right? It's getting a little grim here now, but the thing is, in Antarctica, if you fall in like one of those cracks and stuff, because you got too adventurous and you didn't stick to your like route or something, then somebody going and finding you, that is a mission. And it could be unsafe for them to do that. And so they won't. So then don't. That's why you're not supposed to just go wandering around and falling into cracks because, like, we wear these red jackets there with our name on it so that they find, when they find you, they'll know who you are. And it would be a decision whether they should retrieve it or not because it's a risk to the personnel. Okay? Now, Mars has more interest. Why is that? Because Mars, I mean, first of all, if privately people want to fund going to Mars, like say Elon Musk has a lot of money, so he might have private ways of sending people there. That's different. But if you have the government agencies funding an experiment, then they have to make a very, very good case of what new science will be discovered and how that's gonna advance humanity, because that's the science is about that. New science advances humanity, advances our human knowledge, advances our, you have to find something new in the cosmos. So if there's a very good case, and generally, by the way, another thing that comes to my mind, because apparently I have endless opinions on this, basically, if you want to say set up an experiment on the moon, you have to first prove it out here on Earth. So let's say you have to do some kind of prototyping, which will then make the case that then you should go to the moon and do it because it can be done better there. So you actually have to spend some time, probably years and years, doing something really good here. Like, for example, LIGO, the gravitational waves measuring experiment. I'm just giving an example because I'm not exactly sure about LIGO's plans, but they did a great job. In the last decade or so, we started to be able to measure gravitational waves directly from things like a neutron star merger or a black hole merger, which creates cataclysmic explosions and gives us really big gravitational waves because teeny weeny ones, we're not teeny weeny ones. The smaller gravitational waves or gravitational events we're not sensitive on here on Earth because we have other vibrations and thingamawitches. So, but we made great progress we opened up a whole new arena or a whole new window, eyes into the cosmos by being able to directly measure gravitational waves with something like LIGO, because now we also get gravitational waves as a multi-messenger astronomy messenger thing versus earlier it used to be just light and maybe other particles like cosmic rays and whatnot. Now we also have gravitational waves, but we have to keep in mind, okay, that made us sensitive to some really big events like cataclysmic mergers between black holes or neutron stars, which is still really, really cool. But say you want to be more sensitive to these types of events, then maybe we should put something in space that's orbiting the Earth, or maybe we should put something on the moon. And then you basically proved it out here on Earth and you made the case, hey, we are doing a great job and we know how to do this experiment and we've got results, but we will be more sensitive if we go on the moon because the moon has less vibrations or something, or the moon has less anthropogenic noise. Now, I'm not sure if this is the line of thought of LIGO or not, and someone can correct me in the chat, but see, that would be when they would make a good case of going to the moon. And even then, ideas are always shot down. Someone might ask, like, well, it's going to cost that much more. Maybe that's a great experiment. Like, the best idea could still get shot down because the scientific result that you get out of that experiment might not be something that convinces the funding agencies that year, because they have to give more funding to, say, the military. Right? So, I mean, honestly, why don't you ask Elon Musk or some billionaires, and I'm quite serious, if people have a lot of money, they could maybe make that happen faster than the government agencies, okay? Other countries going to the moon, oh my gosh, Risi, are you telling people that the moon landing did not happen? Is Risi telling you guys that the moon landing did not happen? Okay. Alice, are you here? And, sorry, let's see. I think you should switch out that bot for me. Did you say you went to Antarctica? Yes, I did. Hello, Beyond Ether 222. This channel is about physics, astronomy, cosmology, astrophysics, and kitty cats on my face presenting science. Hello to ex-Christian Sophia. Oh, good. Stephen is saying the moon landing did happen. Thank goodness. Somebody said it. Hello, dear Placid. They once had a restaurant on the moon, but it didn't do well. The food was good, but there was no atmosphere. That's so funny. Serving my Redeemer. That's right. Elon probably does get money from the government. I mean, everybody gets money. A lot of businesses get money from the government. The government does need help with various topics, and the government is not like endless resources, and especially the government doesn't have time to always solve every problem themselves. And so they do, of course, get contractors to help out, and Elon is probably, I'm sure, one of them. But what I mean is, like, Elon has money. Elon and other people like Elon might have the bandwidth to plan and figure out logistics on places like Mars or something, right? And that is a completely different story than NASA figuring out their next moon mission, because NASA has other problems that they're also tackling. So we actually, by the way, speaking of Mars, I know that there's interest in Mars as far as another alternative planet. We did actually, because of that exact interest, we did talk about Mars quite a bit, just to kind of give you an idea of why there is a craze about Mars. I mean, I guess at one point, Elon Musk was talking a lot about going to Mars and living there and things like that, and having sort of the first set of people go there and whatnot. But just from the astronomy point of view, we did cover Mars on the live. We shared a lot of information about Mars, and Mars does have a few similarities with Earth. For example, its tilt, its axis of rotation, the tilt of that is very similar to Earth's tilt. So it basically has similar seasons, but of course the seasons are longer because the Mars year is longer. The Martian year is longer. So things like that. And of course the summers are going to be cooler because Mars is also a lot farther away from the sun than we are. So it's not by any means comfy there, but it is better than the Venusian, atmosphere and things like that, because Venus has a poisonous atmosphere, blah, blah, blah. So we kind of gave sort of an overview of this. So if you're interested, we can do that again as well. Oh, and the surface of Mars is also, I think we read I think this is true, but you should double check that the surface of Mars was also kind of similar to Earth. Like, I think there is a lot of, like, you know how we have a lot of sand, like silicon dioxide, silicates. I think that is the case with Mars as well. So it would feel more like home in that sense. And no poisonous atmosphere, a bit of water. I mean, it has like polar caps, some other ices there too, similar seasons, rocky planet. What else? Not too hot, of course, maybe a bit too cold. More moons. Not as cozy as Earth, but yeah, if you're gonna settle in Mars, actually, I think I remember this from Antarctica as well. They say that Antarctica is sort of the closest to Mars. It's not really. I think Antarctica is really very, very pretty. I mean, and I'm sure Mars is pretty too, but you know, it's colder. So I don't know. I think you can. I think that's like a stepping stone. Like if you're gonna do Martian life, maybe should figure out polar life here first. But I'm trying to think what else were the similarities? Similar seasons, similar tilt, rocky planet, same as us, smaller than us. Get there in a few months. No poisonous atmosphere, but also not a nice atmosphere like ours. Some water erosion proof, so that there was probably water at some point. You know, not hot. I suggest that all my haters should go to Mars. I wholeheartedly support that. Hello, Joe. Santa Claus is at the North Pole, not the South Pole. Somebody asked. Hello, Chris Barnsey. Thank you so much. Can people help me with my goal, please? The super chat goal. Longer to communicate to. Nah, Jupiter. Send them to Venus. I actually really like Venus. Venus is my favorite planet. Except for the fact that it has poisonous atmosphere, I really like the Venusian lifestyle. Venus is very similar to Earth. Size, gravitation. Mars is smaller, so you would weigh less. So if you're conscious about your weight, please go to Mars. See, I am not. I have no problems. So I think I'm an Earth girl. I'm an Earth girl. Benito, what's your problem? Think about it for 24 hours. Whatever it is that is wrong with you, ponder it for the next 24 hours, please, and come back tomorrow night. Thank you. Venus had life. Venus had life, but Venus has always been so hot and poisonous. What do you mean? What do you mean? Hello, Reese. Hello, Steven Sky. Steven is saying, I love Venus and Mars. They have like 16 pics of the surface of Venus from 2 Russian landers. We can't even go to the moon anymore. Hello, Shergill. Venusian lifestyle. Now that's some lifestyle choice. I like the Venusian lifestyle. I am ruled by Venus in astrology senses. Hello, FCID. Why does Neptune get no love? It's so far away. Out of sight, out of mind. Make Pluto. Hello, Francis. Thank you so much for being here and being a mod. Has always been great as a dwarf planet, and it will be. Don't you worry about Pluto. Pluto likes being a dwarfy dwarf. Benito is on his period. Well, according to Top Notch, I didn't say anything. I didn't say that. Grasshopper is saying good gravy, good meat. Good God, let's eat. Earthlings. Hello, Raptor. Hello, Derby. I will stay on Earth with you. Thank you. I really like Earth, guys. I cannot wait to see more parts of Earth. Honestly, when I was young, when I was little, I really did want to go to the moon a lot. I mean, I still do. If somebody offered me a trip to the moon, would I turn it down? Probably not. Because the moon is not too far away. So it wouldn't take too long to go and come back. Because for me, it's very important to come back to Earth. See, Mars is kind of far. And what if they don't give me an off Mars date? Just like they did with the ice. And so, see, I would be a little apprehensive going to Mars because it is so far. And I'm sure there would be so many logistical issues, just like Antarctica, if not, I mean, obviously much worse. And I might not be able to come back quickly. I like my trips short because my children miss me. And so I really can't be going to Mars and all that because it's too far, it's going to take too long, and I don't like the inefficiencies of that. I'd rather go to the moon, honestly, because, I mean, it's close to home and probably we will, I would just have more faith that we would come back quickly. But I cannot wait to see more parts of the Earth and also come back quickly to my home in Boston. Thank you, universe. Thank you. I say thank you for Earth. I like this planet. It has the best of everything. Truth be told. Yes, I do have a super chat goal. Yeah, if you want to help with it, let me see. Goal. That's right. I requested 10 yellow super chats, after which I will do a happy dance and singing and give kisses. So please do help me with my super chat goal, guys and gals. Audalune is saying, imagine if Earth had two polar ice caps and Mars had none. It might be harder to terraform. Imagine if Earth had two polar ice caps. So Earth does have polar ice caps. Oh, do you mean that Mars does? Mars actually also does. The polar caps of Mars kind of change based on its seasons, I believe. But Mars actually also has polar caps, which is another little, what do you call, similarity. Thank you, oh my gosh, Steven. Aw. Steven has done a super chat. Thank you, Steven, my friend. Steven is a member and he did a super chat. Oh, thank you, Steven. Thank you. Send them to Venus. Hello, Steven. Kaufran. This is another Steven saying you are beautiful. Oh, thank you. First name, last name. Have you seen the images from night sky on Mars? I'm not sure what you mean. Are you asking, have you seen Mars in night? I don't know what you mean. I've seen some images of Mars. In-N-Out is hiring on the moon, guys. Somewhat similar density. You have any pictures from Antarctica? I do, but they're on a different account. I used to Google Photos then, and currently I've switched over to Apple. And so all my photos have been here and, not organized, whatnot. So, yeah. Dear Placid, are your parents from India? Yes, and so am I. I was born and brought up there. We're all from India. All of you too. Hello, Muff Diver. Hello, Shergill. Space-Time Theory. Alice, thank you. Alice is saying we did go to the moon. Do you see this, Alice? There are people on my live that don't believe that we actually went to the moon. Can you do something? Can you tell them? They don't believe me. Okay. Doreen is saying, are you Korean? I am not, darling, but I do like Korean pop, if that's what you're asking. Someone on this channel has taught me about Korean pop. K-pop. Oh, and I really love Korean food. Can you? Because you know I'm gonna believe her. We left a car up there. Where? I see a battle low. You can see the landing zone from a telescope. Oh, the moon landing thing? You're saying that there is a battle happening? Mars may once have had tectonics like Earth, but we do not detect any tectonics now. Oh, thank you. What do you think about Starlink and satellites in the future for nuclear missile defense? I just hope that we are safe, my love. I thought the northern polar ice cap here was more like a slushy. So let me read Alice's comment. Alice says some really informative things. So thank you, Alice. Mars may once have had tectonics like Earth, but we do. So, oh, yeah, I was thinking about what else is similar between us and Mars. There are some similarities, but like I kind of pointed out in my live about Mars a while ago, we're much better. I'm sorry. Like for the people who are romanticizing Mars and going to Mars, I mean, more power to you. But like I'm staying here because Mars is like really not that great compared to Earth. Like it doesn't really compare. Like sure, I'm sure it's lovely. I wish it was a bit closer. It's too far. Mars is at what is it again? 1.52 astronomical units away from the sun, right? So we're at, so let me tell you, Venus is closer. So Venus is at 0.7 astronomical units. We're at 1 astronomical units from the sun. And Mars is at 1.52 astronomical units. That 0.52 makes a big difference. Mars is us plus over half of the distance away. So, Venus is closer. This is why I wish that Venus was better for breathing purposes. The Venusian lifestyle